All right, welcome to the beginning of the end. Last unit, sequences and series. So the first one that we need to go through is sequences. So sequence is a list of numbers that follow a pattern. Pretty straightforward. So for example, here's 4 sequences right here. Can you determine the pattern and then find the 7th term? So for example, this is term 1, this is 2, 3, and 4. Can we figure out 5, 6, and then finally 7? So to get from one to the next, hopefully it's pretty straightforward. You just add 2. So 2, 4, 6, 8, 10, 12, 14 would be the 7th term. Take a second and see if you can figure out 2, 3, and 4. Alrighty, so we have the following. 21, okay, wrong thingy. 21 is the 7th term here. 2187, 7th here. For this one, we multiplied by 3 to get to the next term. And here we divided by 2 or multiplied by a half, if you want to get all technical, to get 0.1875. These are considered recursive because they deal with, to get from one to the next, you need to know the one before. But there's a different kind of sequence. There's a sequence that you're given an explicit formula, and n being the term number is included in the actual problem. So, so here, so if a sub 1 would be the first element in the sequence. That's how we write it. A sub 2, second element in the sequence. Sometimes they use function notation where they say f of 1, which never really made sense to me because it looks like it. But you are technically plugging 1 in for n because n is 1. So n is used in the formula just like x would be. So that's really something to help you remember that this is the term value. This is like the y, and the n's are like the x's. So when you're doing these problems, finding the 8th term, this is considered an explicit formula because I can just say, okay, what's the 8th term? And I can, what's the 8th term? Just plug in 8 for n. Done. Okay. So I don't need to know the 7th term to figure it out. So for example, for this one, if I want to find the 5th term, I can just plug in 5. So a sub 5 is 3 to the 5th power. I'm just having trouble finding the eraser. So 3 to the 5th power, that would be 243. So and then if I want to find the 5th through the 8th, I could then find the 6th and the 7th and the 8th. And all we have to do is plug in the 6 for that value. So this one would be 729. This would be 2187. And this one would be 6561. So if you see if you can do it for this one, find the first 3 terms of this problem. Okay, so a sub 1 is 1 plus 2 over 1. So anywhere there's an n, I'm plugging this number. It's just like f of x and those kinds of things. So this would just be 3. So I plug in a 2. So everywhere there's an n, I put a 2. And for this one, everywhere there's an n, I put a 3. So each term is dependent on what term number it is. Fantastic. I left that blank. Couldn't think of another. I didn't want to do another one, so whatever. All good. So what term is it if the nth term? So this is using it backwards. So instead of giving you x, I'm giving you y. Pretty straightforward. So we're giving you the entire term value. So if this is the nth element is 224, not n, the nth element. Okay, so that term is, I don't know what n is though. what is that term number. So remember, n is the term, the nth element or the nth term is the actual value when you plug it in. So we just can solve here. Divide by 3, and n is 74. Okay, same deal. Try it with this one and see if you can figure out what term you're at. All right, so hopefully you got 26 and all is well. So now the fun begins. We have a recursive sequence. Now I know you've seen this before, but just as a reminder as to what these are, we're just going to spend a couple seconds on them. So this looks like the ones we did on the front. So this is the first, second, third, fourth, fifth. How do I find the eighth? Well, I have to figure out the pattern. They're adding 3 to get to each one. So to get to the eighth, I would simply find the sixth. This is the fifth. I would find the sixth, which would be 21. Sorry, the seventh would be 24. And then the eighth would be 27. So the eighth term would be 27. Oh, no problem, Ms. Barris. I can do that. We'll find the 95th. No, I don't think so. All right, so that's the idea, though, because you say no, because I would have to find the first 94 to figure that out. Computer or something might help, but at the same time, I don't want to. Okay. So when we're doing these, the notation is the same as it was in the other ones, where you have a sub 1 is the first term. So in this case, a sub 1 is 7. In this term, a sub 2 is 10, a sub 3 is 13, and so on. And then we get to the nth term. So this is the nth term. So the one before it, I spread it out. I'm not quite sure why I spread it out, but because I didn't want to get too clustered up. This one goes back a term. See how it's n minus 1? That literally means, let me look at the one before. So if this was the 8th term, this one here would be the 7th. It's 1 before, yes? And if this is the 8th term, if I do n plus 1, this is going to be a sub 9. And this should have been a plus 2. That's a little bit of a typo there, but I'm too far into it now. So this would have been a sub 10. So that one was supposed to be a sub n plus 2. I must have copied and pasted and not done right. Okay. So when we see something like this, a sub n minus 1, that means whatever term I'm at, I want to go 1 back. So 1 back, 1 term before n, before what I'm at right now. So in this case, well, this one right here, what is a sub 1? We went through that already. A sub 1 was 7. So remember, 1 is what term I'm at. 7 is the actual value of the term. So let's say here I'm looking for n. If n is 5, what is n minus 1? Well, I can plug it in if I want. A sub 5 minus 1. That would just be 4, right? 1 before. What's a sub n plus 1? Well, if I'm 5, that's 6. Right? Just like 8 became 7, and then 8 became 9, just by adding or subtracting to it. So that's what these subscripts mean when we're doing these recursive problems. Okay? A sub n minus 1 just means whatever I'm at right now, I'm looking at the one before. These recursive ones are just like the top one up here, where it's just based on the one before. So I'm going to be adding 3 to get to each successive one. This one right here is I'm going to be adding 1 to get to the next one. And it's literally as easy as that. It's just the notation tends to look a little bit confusing when you're doing it. So if I want to find the first 5 elements here, well, I know the first one, they give me that. A sub 1 is 5. So what's A2? Well, it's 5 plus 1. Okay, because this one means whatever one was the one before. Well, I'm at 2. So the one before it was 1. is 5. So that's 6. So here, a sub 3. Well, I have to look this thing right here, this a sub n minus 1, which would be a sub 2. I don't know why I put the parentheses there, so I apologize. I don't want to confuse you. So it's a sub 2 plus 1. So this is a sub 2. I just figured that out. So it's 6 plus 1, or 7. So 4 would be 7 plus 1. And 5 would be 8 plus 1. So the first 5 terms are 5, 6, 7, 8, 9. Okay, yeah. Seriously, Ms. Bears? That's a really easy form. But the formula looks difficult, so we have to start out with easy problems to kind of help you grasp it. So here, a sub 1 is 1. So I found the first term already. So now I have to find the second, the third, the fourth, and the fifth, because I have to find the first 5 terms, because that's what the directions say. So I have to do 2 times a sub n minus 1. Well, I'm at 2 right now, so the one before it is 1. So it's 2 times 1. Yeah, I just did that. 2 times 1. I did it. Okay, so see if you can figure these out and finish these, and I'll come back. Okay, here are the first 5 terms. 2, 4, 6, and 8. Okay, so we just took whatever the last one was and plugged it in. This one goes there. That one goes there. So this one goes here. The previous one always goes into the last one somehow. That's what recursive means. It means that one term is based on the one before. And that's it. All right. This one includes n in the actual problem. So when we're doing a problem like this, so a sub 2, because we already have the a sub 1, we always have to be given at least one of them. We're doing the one before, which would be negative 2, plus n. So this is n right here, so that's just going to get plugged in. And that would be 6. Okay, so then this one, a sub 3, would be negative 2. This means this one goes in. Plus, what's n? I'm the term I'm at right now? Well, that's 3. And see if you can finish these 2 out. Okay, so this should be the 3, they're the 2 that you got. So I put this negative 9 here. The term number is 4. And then I put the 22 here. The term number is 5. So that's the n right there. Okay. All right, for this one, it's written just a slightly different way. You have this one here. It says n plus 1. But if you think about it, this is really just 1 before that one. So it's really just the same thing. The only thing that's going to be slightly different is that n. Okay, that n is going to be 1 less than what we want it to be. So if I want to do a sub 2, because that's my next one that I need to be, I got that by doing a sub 1 plus 1. So that means that this n right here is 1. So this still means the term before, but in this case, it's just going to be 1 less. So I don't want to confuse you too much by this, but this is still 1 less than this one. So I'm still going to go, this is 5 plus, but instead of 3, I'm just going to do 2. And this is a sub 4, so it's 7 plus 3. And this is a sub 5, and this is 10 plus 4. So those are the first 5 terms there. So for this one here, this is more likely the kind that you'd see if you're going to see them. It's n minus 1, n minus 2. So that means the one before. Oh, wow. Can you even read that? And then this one is 2 before. That says the same word. Before. Yeah, I rock. But anyway, that's what it means. Okay? So when we're doing this, a sub 3, so now we already have 1 and 2. So all we have to figure out for the first 5 terms is 3, 4, and 5. But in order to do that, I need these two. So this one is the one before, so that's a sub 2, 1 under 3, so that's 2. And this is 2 back. Okay, so the first one is 1 back, so that's this one. And the second is 2 back, so it's that one. The first one is 1 back, so that's this one. The second is 2, that's this one. Done. Okay, so that's all that means. Go back 1, go back 2. Try this one and see how you do. Okay, to finish this off. Okay, this first one goes 1, so this is 1 back, so we go from 3 to 2. This one is 2, so we go to here, so we get 10. So we get the 10 because with this one is the first one should be 1 back, the second one is 2. So I get 18. This one right here, I get the 1, and this one right here, I go 2 back. So we get 38. All right, good luck. Have a wonderful day. Enjoy math.